Hello. This presentation will explore urbanism and sustainable neighborhood design. I shall present this topic in three parts. First, an introduction to cities and development in the tropics. Secondly, urban design approaches we can adopt. And lastly, an introduction to the local climate zone protocol as a means for making informed decisions in the urban scale. Urban growth is the highest in poorer parts of the world, where the capacity to provide infrastructure is the weakest. Our knowledge of the fast-growing cities in the poorer parts of the world is very weak. These cities, whose urban forms are hardly known, are emerging at a time of concerns for resource depletion and global climate changes. Urban population pressures and increasing personal wealth will demand better urban quality of living. Demand for better quality of living and better outdoor spaces require response to urban heat islands and adaptations to it in an increasingly warmer world. A heat island is best visualized as a dome of stagnant warm air over the heavily built-up areas of the city. These have been observed practically all over the world. The effect is not so much felt during the day, as the increase in the maximum temperature is minimal. However, heat islands are intense at night, occurring a few hours after sunset. This has far-reaching implications for urban design, especially in the equatorial tropics, where the nighttime thermal stress is usually high. The widespread incorporation of the tenets of sustainability into planning offers an opportunity for including climate and weather issues into urban design. Action remains within the urban planning and design domain, and the phenomenon of UHI offers both a focal point as well as a policy opportunity for cities to contribute to the issue of adaptation to climate change. We shall now present a few design strategies. Evidence from the warm, humid tropics indicate that shade, either caused by buildings or trees, to be the single most important design parameter in determining local warming and cooling. We can shade by modifications to the nature of the building edge, using overhead planes, use of landscaping, particularly shady trees. Ventilation has been a key strategy for thermal comfort and pollution dispersal in hot climates from ancient times. However, the low levels of wind speeds in the tropics due to passing of the intertropical convergence zone twice a year makes it necessary to carefully map out the ventilation strategy at a citywide level to induce sufficient air movement, both for pollution dispersion as well as thermal comfort. It will also enhance the cooling potential of naturally ventilated buildings, which is the most common approach to indoor cooling in the warm, humid tropics. In the typically low wind speeds prevalent in tropical cities, the effect of facade materials and their colors assume greater significance. The higher the albedo of the surface, the more sun that is reflected and less heat stored. The lower the albedo of the surface, the more sun that is absorbed and the more heat stored. The importance of urban greenery to human comfort at street level is long recognized. However, efforts to use greenery to ameliorate urban warming needs to be conscious of the scale of the effect due to different kinds of greenery, limitations of its use, and the unintended consequences of the haphazard development. The microclimate of the context is critical for buildings in the tropics. In order to adopt strategies that incorporate natural light and ventilation, the environment around needs to be conducive to the approach. To aid the process of evaluation of the microclimate and the making of the informed decisions, we look at the local climate zone classification system. The local climate zone, or LCZ classification, is a recent development in urban climatology. Beyond its intended use as a classification tool, the LCZ system may help to fill a crucial void in UHI methodology. That is, the lack of an accepted protocol to gather and report heat island observations. Here, we explore the case of Colombo, Sri Lanka. The two maps compare the existing and the projected maximum development in terms of LCZs. The table demonstrates the UHI intensity of each particular local climate zone. We clearly see the compact high-rise zone generates the highest UHI intensity. Therefore, the changing morphology of the city into more compact and dense development will drive the UHI intensity even higher. Taking this as an example, we see the grave importance of making informed decisions in the urban scale, a step essential in developing cities of the tropical world in general and the microclimate in particular. Thank you for your attention.